Hello, welcome to the Lattice Developers Conference. My name is Ricardo Shiroma. I'm here with Steven Morgensen, and we are going to talk about how the Lattice is enabling next generation smart PCs and peripherals. Hi, as I say, my name is Ricardo Shiroma. I joined Lattice about 3 years ago in the role of business developer for the client segment. Before joining Lattice, I spent about 20 years with HP and Dell in several product development roles. I'll let Steven introduce himself.
Good day. My name is Steven Morgensen. I work with Lattice in the client segment, focusing on Glance software. I joined Lattice 2 years ago as part of the Mirametrix acquisition, and we look forward to presenting today.
All right, so going for the agenda today, we talk a little bit about the evolution of the PC experiences, how those are shaping, and the role of computer vision in those experiences, and that's how Lattice and Mirametrix partner and to deliver the best solutions in the market today, right? We will show some of the real-world implementations that we are were in the market today, and as well as talk about the future, right? What is coming down the pipe and some challenges that we believe that everybody who is working in computer vision is going to face. Back to Steven.
So, the evolution of the PC experiences. Over the years, personal computers have transformed from mere productivity tools to a key component and integral part of our daily lives. The demand and expectation of PC users has evolved significantly, driven by technological advancements and changes in user behavior, which we've experienced tremendously over the past 3 years. Traditional usage, such as word processing, data entry, have expanded to encompass a wide range of usages and activities, from entertainment to gaming and productivity and creativity. So as you can see from the graph and the illustration, PC usage dominates our daytime activities, and in many of our cases, nighttime and evening activities as well. Increasing collaboration features such as video conferencing has made PCs even more essential to our daily usage and productivity. The nature of sheer volume of PC usage has driven new sets of requirements to support users and their realities. So devices going forward must be compact, light for increased mobility, with enhanced privacy and security features, all while maintaining optimizations for power and performance and long battery life. Lattice's PC solutions consists of an end-to-end platform for high performance experiences, enabling smart user-aware devices across portfolios. This includes both the hardware and software FPGA with an AI algorithm offering, and a software-only solution by Glance by Mirametrix to support our clients' smart device goals and their existing and targeted architectures, while always focusing in any case and any implementation on power efficiency and optimized performance. Computer vision, the field enabling machines to interpret and understand visual information, has become a cornerstone of modern technology. Implementing computer vision algorithm requires significant computational resources, which often poses challenges in terms of power consumption, latency, and real time, which will be addressed further in this presentation. Ultra-low power FPGAs from Lattice offer a compelling solution to address these challenges while enabling advanced computer vision capabilities. At its core, an FPGA is a reconfigurable hardware platform that allows developers to create custom digital circuits tailored to specific tasks. This flexibility lends itself well to computer vision tasks, which often involves intricate image processing, object detection, and pattern recognition. By configuring the FPGA to execute these algorithms directly in hardware, developers can achieve remarkable speed up and efficiency compared to software implementations on traditional processors. Lattice focuses on ultra-low power FPGA technology is particularly advantageous for applications where energy efficiency is paramount. These FPGAs are designed to execute computation with minimal power consumption, making them suitable for battery-powered devices and systems that require extended operational lifetime. such as PCs. This is crucial in scenarios like edge computing, where devices need to process visual data locally without draining the power resource rapidly. Parallel processing of FPGAs aligns seamlessly with parallel nature of many computer vision algorithms. These parallelisms enable multiple tasks to be executed simultaneously, resulting in faster processing and lower latency, which is crucial for real-time applications like robotics, surveillance, and interactive user interfaces. Furthermore, the reconfigurability of FPGAs allows for iterative optimization. Developers can fine-tune their hardware designs to achieve the best performance for specific computer vision tasks, adapting to changing requirements of algorithms or algorithm updates without altering the hardware itself. Ultra-low power Lattice FPGAs provide an exceptional platform for implementing computer vision capabilities. Their reconfigurability, parallel processing capabilities, and emphasis on energy efficiency combine to enable the deployment of advanced computer vision algorithms in power-constrained environments. Core to our computer vision strategy are the advanced AI algorithms that came with our 2021 acquisition of Mirametrix. The Mirametrix Glance AI-based attention sensing software engine leverages standard image sensors to understand human contextual awareness. Our advanced attention sensing engine captures 3D information of the users, their position, orientation, and attention, including many capabilities. Some examples include face position, user orientation, face landmarks for single user and multi-users, gaze direction, as well as other image enhancements such as background subtraction, illumination correction, user enhancements, user framing, hand gesture tracking, fatigue detection, user identification, object detection. There's a lot of information that's captured and leverage with these AI algorithms. So all this metadata that's captured within our AI attention sensing engine is then used to develop smart user experiences as part of an application called Glance by Mirametrix. And this can be leveraged by our OEMs directly or through their software control interface. So Glance, as an overview, Glance is an AI attention sensing engine application that leverages the attention sensing engine just described to detect a person's presence and follow what they're looking at in real time. Glance then converts eye and head movements and all the capabilities that we just described into data and translates them into insights that could be used for a wide range of tools and features around privacy, productivity, digital wellness, and intelligent collaboration. And to go into some examples, privacy, so a device understands when a user is in front of the device, when they leave their device to automatically lock it to protect information. Other examples, such as onlooker detection to allow a user to know when someone is looking at their information over their shoulder or beside them. Examples of productivity include multi-monitor usage, being able to know which device you're focusing on and where your content should be located based off of where your attention is, if it's on your main display or if it's on a second or a third display. Digital wellness is a very popular feature. Understanding how much time people are spending on devices. Screen time is very, very important. Notifying a user when they may want to take a break is important for not only children, but for adults as well. Identifying when someone is blinking too much, that they may have an eye condition or maybe developing an eye condition or dry eyes because they've been spending so much time in front of the device. And we're seeing a lot of this in areas such as gaming, but even in daily usage. And intelligent collaboration is obviously very popular today. Video conferencing is key to everybody's daily work activities. Not only is it about how we interact with the image feed, but with our environment and how we're enhancing the image feed. We've seen camera quality increase over the past couple of years, and we will evolve and update our solutions to support this. But these are obviously very popular usages, and this led us to enhance our our capabilities beyond just face and eyes and mouth movement, but also into objects and hands to complement. Each of these areas, as well as other areas, as I mentioned before, avatars, have their own roadmaps, and we work closely with our partners to advance those roadmaps, to support new devices, to support new cameras, to make sure that we enable the smartest user-aware devices based off of the device capabilities. Now, Glance by Mirametrix is a mature product. We've been in market. It's been in market since 2017. It ships on millions of devices across multiple OEMs. It's flexible. It's designed to support our customers and partners' existing infrastructures, what cameras they have, what hardware they support. We have as discussed earlier, an advanced FPGA enabled version. But we do work with our customers to support their hardware direction. It's a turnkey solution. As I mentioned, we have Glance. This is an application that has been shipping for the better half of 7 years. But we can also enable, as mentioned earlier, our OEM partners' software interfaces should they have one. We're constantly building roadmaps to support all of the areas, the categories of user experience, and this is in collaboration with a team of 60 plus people in Montreal that have experience delivering the solutions for multiple years now. We're creating the solutions, we're delivering the solutions. We understand the nuances with devices and delivery, and through Mirametrix, Lattice offers this fully staffed AI lab available to collaborate with our partners on roadmaps of advanced AI user experiences, and also on delivery of those experiences and any customizations that may go along with that.
Taking back from Steven, thank you, Steven, for the initial slides. Let me try to tie back about how Mirametrix and Lattice solution come to the PC space. We talked a little bit in the beginning about how PCs are important during our day-to-day activities, but Lattice and Mirametrix also got into the partnership in the middle of the pandemic. And a lot of the evaluation and use cases that we were developed back then is still applicable today, or even become enhanced as the users coming to this new work environment where people are working from home and working from the office, right? And in multiple cases, going to offices where you no longer have your own desk. You're working in hot desks. That brings new challenges to the PC users that are related to privacy, security, battery life. And to the PC OEMs, of course, is to pack all those solutions into a very small and compact box, because portability is also important. So we're starting with the first box, where PC users now and more than ever need privacy and security. We enable solutions that allows the PC to wake up faster by checking the presence. So when the PC is open and the camera is looking to the environment, if nobody's there, the PC will be turning off. But when somebody's approaching, it will turn on before the user has to push the power button, right? And if the user leaves, the PC is going to automatically lock and eventually turn to sleep, right? This enhances the security of the solution, because the PC only is accessible now by the user as it should be. And not just that, but it also helps with the power savings because we can put the system back to sleep. Power savings are not just by putting the system back to sleep, but we can also increase the battery life by tracking attention, as we have access to the camera and we can see whether the user is looking at the screen or looking away. By using that, we can control the display and reduce the brightness, which over time leads to more battery life. That also help us with privacy, because if the user is not really paying attention, people will not be able to see what is on the screen as well. Which is the next use case that we support is the onlooker detection. So if there is somebody trying to peek on your screen or working behind, especially on those open spaces, hybrid offices, like if you are on public locations, we can detect if somebody is trying to look at your screen and alert the user and take actions such as blurring the screen, blurring the content, and that will prevent unauthorized users to capture what is happening on your screen, and preventing maybe confidential data from the company to be taken. As I mentioned, integrating all those solutions cannot come at the expense of costs and cannot come at the expense of a battery. So we help the PC OEMs to find ways to simplify the design, not just the design itself, but we want to make sure that we help our PC OEM partners to have a simplified supply chain, secure supply chain, and delivering a design that is end-to-end solution, uh, and allow them to integrate even more features in the design in the future. Talking about some real use cases where our solution has been adopted. Uh, Lenovo is one of our first use cases with the ThinkPad X1 Yoga and X1 Carbon, where they decide to use the Lattice FPGA to accelerate their computer vision context awareness solution. And not just using the FPGA to do the computer vision, but Lenovo also uses Mirametrix Glance as their user interface software to control several of their more advanced user experiences. So this is a really good use case where we're doing end-to-end integration from the sensor all the way to what the users touch and feel. Another real-world implementation in the client space is the Asus ProArt Studio 16 with the 3D OLED display. Similar user experiences. Asus was concerned as this is productive, like a creator device that requires a lot of power for the creators using graphics, creators using rendering softwares. They want to make sure that those users can have productivity on the go, right? So that's why they selected the Lattice solution with the attention tracking to help them improve the battery life of their systems. And as we are learning in the market with those devices, we find some design considerations that we need to take to the future for the next generation PCs, where user experience benefits are essential, and we need to acknowledge and address those challenges and considerations as ensuring that the FPGA adoption for smart and private and collaborative user experiences is critical. Uh, Design complexity, right, is something that we face every day, right? As I mentioned, there are challenges in terms of size, thermals, and or cable management and other solutions. That's where the FPGA shines, because we can help with the hardware designs, right? And the field programmable allow us to go and adjust as and customize the solutions to the future, right? We don't need to be optimizing for a particular algorithm. We can help and improve the solution, right, as we go and for after after market updates as well. The integration and compatibility allow us to adapt to new algorithms, as I mentioned, right? As we can improve the power consumption or the efficiency, or even adjust to new and challenging environments, right? In the beginning of the pandemic, right, when our solutions start to be uh, tested or evaluated, nobody was wearing mask, and mask become must have, right? As people start to wearing mask during the pandemic, right? So by allowing these adaptations and allowing our solution to be flexible, we could adjust and incorporate mask detection as part of our algorithms without any hardware change, right? Just by updating the algorithms and update the hardware to enable those those differences, right? And as well as time to market is really important, right? Even though the PC market goes into an annual cycle for refreshes or updates, they want to always to compete and be ahead of the other OEMs, right? By adopting FPGA, we allow the flexibility, right, to be the most updated solution when it comes to the market, right? Not just that, right, but we can continue updating and improve the user experience to make sure that everything is consistent, everything works, right? And if there any change on the user environment, we can also adapt to that, right? And as we are working with those client PC OEMs, right, to understand that utilization of resources in the FPGA is very critical. And this is on a legacy of what Lattice has about working in low power. So allocating the resources efficiently, allowing the lowest power on our devices, and looking to the end-to-end solution are really important challenges and considerations for the PC OEMs. And by addressing those challenges, right, we help the PC OEMs for successful integration of the FPGA in our software stack with the Mirametrix Glance, right, that allow us for innovation, improve collaboration, and ultimately leading to the creation of enhanced, reliable, and user-friendly computer experiences. As we show and talk about the challenges and considerations, we talk about the solutions, but we see the PC of today using AI in ways that can use the context of the user to improve privacy, security, uh, understand the capability of what is happening to improve image quality, and user and a lot of users that are on demand in the PC as well. The biggest change that we see in the PCs going in the future with more and more AI become part of that, right? With the generative AI coming part of the equation as well, is that the PC will becoming more adaptive for your personal use. As today, PCs coming out of the box and behave the same, right? You have to spend a lot of time in customize those solutions. As we look into the future of the PCs, that customization will be learned by the PC itself, right? Learning and understanding how we use the PC and adjust to that behavior. Learning how you type your emails, what context are you typing those emails, right? And even make suggestions for that, right? Understanding what you are doing. Uh, are you doing a presentation? Are you working on Excel? Are you playing games, right? And making adjustments in terms of performance, power savings, to that environment. So everything in the PC experience going to the future is going to require some level of AI. And Lattice and Mirametrix are working with the PC OEM to understand uh, which direction they want to go and create a roadmap of future innovation. And as we look into a roadmap beyond 2025, we are really looking to create great devices that are aware of the user, right? By driving even more solutions for privacy and personalization, right? Such as Face ID and Voice ID. So not just knowing that the user is there, but also knowing who the user is. And as those those solutions come to market as well, we are looking to ways to adapt for new user interfaces, right? By using gaze tracking, gesture tracking, and understanding not just the user but also the environment, right? So by becoming aware of the environment, we can definitely help the PC OEMs to create innovative solutions, right? And I help them to adapt their PC to the user environment. But all those new computation cannot come at the cannot come with degrading battery life, right? Battery life is going to continue to be important. So power efficiency continues to be a very important uh, topic for the PC OEMs, right? And that's where the low power FPGA and now the optimization that we start with the software developing glancing, porting those solutions to the FPGA can help the PC OEMs, right? Developing efficient AI models, solutions that are going to run on the best silicon as we can develop the software to run at the CPU, at the GPU, at the NPUs, right? Or the FPGA, right? And that pipeline can work across those different silicons to provide the most power efficient solution. Work with the entire ecosystem to understand the interfaces, right, and be ahead of the interfaces. And IO has been always one of the reasons to use FPGAs, right, and that's we want to continue to take advantage of that. And looking to not just uh, understand the awareness of the PC, but also what is happening on the system, right? And by combining both, right, we expect that we can drive better system level power. And one of the focus area for us is the video conference because we are using the cameras to detect all the awareness. And as we are already there, we are working in a lot of solutions to improve collaboration and video conference by enhancing images to come with other solutions such as avatars when the user cannot use the camera but he wants to be expressive and contribute in meetings. Multiple sensor support, right, where the FPGA is really agnostic to the newer cameras and help with the audio and video integration. As I mentioned, also simplification continues to be area of focus, right, where the FPGA cannot just deliver all those new great experiences, but we can help by simplifying interfaces, by incorporating new users, new sensors, by bringing USB, by reducing MIPI cabling, uh, by integrating features that today are done by other solutions such as ambient light sensors, color sensors, and we are not just doing that by ourselves. We are integrated with the Intel and Microsoft stacks, right? As a part of the client PC ecosystem, we are working closely with Intel and Microsoft to make sure that our solutions are fully integrated and will deliver the best end-to-end user experience. And I want to just show one example of innovative solution. So gaze tracking per se is not a new solution in the market, but we are driving a better solution today by using just a single camera and be able to track the gaze, right? So driving new user interfaces, new use cases that are driven without adding costs to the PC OEMs. That is how we are helping to drive a completely innovative solution and ecosystem in the market beyond 2025.
All right, so now we'll skip on over to the Q&A portion. We have a couple of questions that have come up already, so I'll start. Ricardo, do the PC OEMs have or require FPGA engineers to support Lattice solutions?
So most of the PC on the client space, they do not have FPGA engineers, right? It's not reality when you go to servers or workstations, but on the client, they do not have FPGA engineers. They do not need FPGA engineers. So today, Lattice is design an end-to-end solution, right? From the pretty much sensing connect to the camera all the way to the user interface with the Mirametrix class. And we provide that as part of our solution to the PC OEMs. But if customers want to get the same level of integration, Lattice provides design services, which would be very similar to how we're supporting the PC OEMs today, right? Where there is not really needed to have FPGA engineers to take advantage of our AI computer vision sensing stack. All right, so Stephen, I think we have one that you can answer, right? So what applications can take advantage of gaze tracking today, right? And I think it's worth not mention just on the PC, on the PCs, right? But in general, right? We're seeing traction about gaze tracking.
Sure, great question. From our perspective, gaze is just one of many inputs, and as we went through earlier, the various capabilities and all the information that we capture from all the head movements and head orientation and eye movements and user depth, etc. For all user experiences, we gather all that information, that enriched information, and we leverage it to whatever is required to support a specific usage. And I think that when we look at gaze in particular, where someone's looking, it's often combined with your head movements. It has to be natural. Rarely are people just moving their eyes to do something. So we take that into consideration, and there are several areas which we think could be very interesting for gaze, such as selection, being able to look at a portion of the screen and maybe even combine that with another modality, maybe with voice or maybe with a gesture. But at the end of the day, it has to be natural. It has to be robust. I think on the Mirametrix side, we've spent years working on really delivering a very robust gaze selection capability that leverages a standard image sensor. We're talking VGA, RGB webcams, low quality webcams. Obviously, we can take advantage of higher quality, but we've really developed our system for that. So what we like to do is for all use cases and user experiences, we like to sit down with our partners. And we have this great lab in Montreal with really experienced people on developing and delivering user experiences and working with our partners' user experience teams. And we'd like to sit down with them and take a capability such as gaze and look at their product vision and strategy and the messages that they want to deliver with their product, and then execute on a user experience that is suitable and would advance and drive the story that they're telling with these devices. So there are many applications, from selection to security, and especially even outside of PC in areas like industrial, where there's very good value and there's a strong value proposition for gaze. But it's endless in terms of how else we can apply these. So we look forward to working with our partners and people listening to this presentation today to further define user experiences customized to your organization's needs. Well, I see there's another question here, Ricardo. How can Lattice solutions improve video conferencing?
Yeah, that's a great question, right? And Lattice, as being always in low power, but also has a legacy in video solutions, right? And FPGAs being used across multiple industries as ISPs, right? We have a very good understanding of the image quality pipelining. And as we acquire Mirametrix, where they are looking to user awareness, but also into AI, right? I think having this end-to-end understanding of the image pipelining and the users in front of it, and being able to incorporate AI, that's really how Lattice can help to improve the solutions by going to image enhancement, right? Or even thinking about, hey, even if there is no user, right? How can we understand and make an avatar that the user can express itself by understanding everything that the user is doing, right? Can I look into if the user is talking, right, and mute undesired noises from the background, or alert the user that he's not talking? There are other challenges as we look into video collaboration, which is sensors, especially in the PC space, that are improving those sensors, right? And catching up with multiple sensors, configuring multiple sensors, higher resolutions sensors. That is an area that the FPGA can shine, because we can quickly adjust and faster adapt for the needs of the PC OEMs. And as you look into the awareness, we also start working on how to integrate audio, right? So understanding when the user is far away from the PC or close, right? Can we work with improving and enhancing the audio? Understanding where the user is looking at, can we make the spatial audio better, right? So understanding if their solution is on a environment that is closed, or if you are in an open environment, can we change the settings automatically? So a lot of those context awareness and understanding the scene, right? Plus understand the full image pipeline AI. Doing that integration is where all the Lattice Mirametrix power are coming good together to deliver better user experiences. All right, so
great, and another one just came in, and maybe it can follow up that the great comments on video conferencing. But how do you expect generative AI to be used in PCs?
That is a new experience, and that we are seeing in the past year or so, that people are gravitating towards using those generative AIs to improve productivity, collaboration, creativity, and there are a lot of opportunities for generative AI coming to the PC workflows. A lot of the chatter right now about using generative AI in the PC environment or in the this user context is about improving uh, customer experiences, right? Or like sales experiences, where you can use the generative AI to accelerate those workflows. The other area is about the creatives, right? With stable diffusion and those other type of solutions to accelerate product design, to accelerate content design, right? And that those are the areas that people are looking into that, right? But most importantly, the discussion has been how do you make that at a power efficient level? How do you make those solutions to live inside the PC so you don't have to rely on internet connectivity, right? And as you think about more about some of those challenges, how do you make that so your data is not being sorry, let me start that one again. Hey Steven, can you ask that question again? Because I just touched my mouse and moved the display.
Sure.
All right.
Okay, thank you, Ricardo, for the response on video conferencing, and maybe to build on that, how do you expect generative AI to be used in PCs?
That's a great topic, right? In the past year or so, there's a lot of attention in generative AI, right? With the ChatGPT and the other solutions that are similar, right? Using large language models or even image stable diffusion, right? For creatives. And a lot of those experiences are being taught how to come to the PC space, right? Some of the applications are very clear. It's kind of helping with product design, help with the creative process, help with customer management, right? As you write emails, uh, help with other solutions that are related with all this creative, all our work process workflows. But today, a lot of those experiences around generative AI are done through the cloud, and that means that you require to be connected to the internet. And the challenge on the PCs is bringing that to be all integrated and living to the device itself, consuming less power, and be relevant to the user. And not just that, there are privacy concerns and IP concerns. So the having the data contained in the device is going to be important. So generative AI coming to the PCs will help a lot into those areas, but it's also going to have the challenges about all the models and all the processes be contained in the PCs. That's where we are also working with the PC OEMs to understand those requirements, right? And driving solutions that will help generative AI and new user interfaces, right, to be used by the PC OEMs. Of course, the first level is coming to the office applications tools, right? That is the first step, right? But how do we make that data contain and more available and more customizable? That's where we want to find our partners to help with solutions that can give the best user experience.
Yeah, it sounds like an opportunity to work with our partners to really define how this new technology can be used to enhance their devices.
100%, right? Generative AI is a new technology, a lot of eyes on that, right? But there's also a lot of challenges with how large the models are. How do you keep your data protected, right? And how you do not violate IP and other things around these professional areas, right? That are also important for the PC OEMs, right? And for their end users. All right. If you no further questions, I think we'd like to thank you everybody for joining our session. Right. If you have submitted questions and we were not able to answer yet, we'll follow up and provide you the answers, right? But we really appreciate everybody who joined our session. Thank you.